This video will show you how flyback diodes can be used to stop the voltage spikes created by motors from crashing your Arduino. This circuit shows a simple coil of copper wire. Electric motors contain many copper coils like this. Here is a simple motor with 3 coils, but most motors have many coils like this one. When an electric current flows in a coil, it creates a magnetic field in and around the coil like this. When you try and turn the current off, that magnetic field generates a huge voltage which tries to keep the current going. This voltage is often large enough to force the current to jump the gap where the switch has been turned off, creating a spark of lightning at the switch terminals. Here is a clip of a coil which has been turned on and off rapidly by a vibrating switch. The voltage created each time the switch turns off is responsible for the sparks that you can see. To make electricity travel through the air like this takes about 10,000 volts per centimetre. So if this spark is jumping an 8 centimetre gap, the voltage must be around 80,000 volts. This coil has been deliberately designed to produce sparks, but the coils in any electric motor are quite capable of producing sparks too. In our case, the trouble is that the high voltage can drive current back into the Arduino and either cause it to reset or physically damage it. To control this voltage and send the current harmlessly somewhere else, we use a flyback diode seen in this diagram. When the switch is opened to turn the coil off, the high voltage can now send the current harmlessly through the flyback diode instead of back into the power supply. On the L293D motor driver chips that we use, the D stands for diode. This means that the chip has flyback diodes built into it to suppress the electromagnetic interference generated by the motor.